Now let's find the oblique asymptote of this rational function. Now the reason why we know it has an oblique asymptote is because the degree on the top is 2 and the degree on the bottom is 1. So with that in mind, that means it does not have, I'm not sure what that is, it doesn't have no horizontal asymptote. And it does have an oblique asymptote because the degree on top is 1 more than the degree on the bottom. If that were x cubed minus 4 over x plus 4, there'd be no oblique either. But since it's exactly 1 more, top is 1 more than the bottom, it does have an oblique. To find the oblique, we're going to use long division. So we're going to set it up like this. X squared. Now, let me show you. Here's what I was going to write, or I am going to write. But the thing is, I can't use that yet because I'm missing the x term. So since I'm missing the x term, I'm going to use 0x as a placeholder. And now I'm going to divide using long division. I'm going to divide x into x squared. That x is going to cancel one of those, leaving an x. So I'm going to put that up there. I'm going to multiply it back through. X times x is x squared. X times 4 is positive 4x. Then we subtract, so put the minus signs in. These cancel out, and 0 minus 4x is negative 4x. Bring down the minus 4. Divide x into negative 4x. X is canceled, leaving negative 4. That goes on top. And in all actuality, I don't have to do anything else because I'm done. Let's just go ahead and multiply it out. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. Subtract. Does become a positive. That leaves us with a 12. But we don't use the remainder in our oblique asymptote because the oblique asymptote or slant asymptote, whichever book you're using, may use that word, it's going to be y equals the quotient. We don't care about the remainder. It's always y equals the quotient, which in this case is x minus 4.